Let's see how we could use these problems to simplify expressions that are written in logarithmic form. We have log base 5 of 5 times the square root of 7 divided by 3. All of our problem will involve log base 5. Log base 5. Here's a product, 5 times the square root of 7. So that means we're going to add the logarithms of those two numbers. 5 plus log base 5 of the square root of 7. And then we divide. When we divide, we subtract the logarithms. So we'll subtract log base 5 of 3. We're not done yet. The log base 5 of 5, that's a simple property that says, oh, well, the log base 5 of 5 is 1. Let's continue. Log base 5 of the square root of 7. We know that the square root of 7 is really the half power. And so we can use the power property and say, well, that's really 1/2 log base 5 of 7 minus log base 5 of 3. And there we've expanded the logarithm of an expression by using the log properties into this larger expression. Now it's time for you to try one. Use the logarithm properties to expand and simplify the log base m of the square root of 5r cubed divided by z to the 5th. Turn off the tape to do your work and turn it back on to see the results. Let's see how you did. Let's see now. We have the square root, which is the 1/2 power. We have a log base m. The square root is the half power, so the whole thing is 1/2 power. Let's put that 1/2 out there. And we'll now have 5r cubed over z to the 5th. Now we'll do the same as we did before with our first example. We have 1/2. We're going to put parentheses around this. I hope you remember to do that. And write log base m of 5 plus 3 log m of r, because that was r cubed, and we can use that property, minus, because that's division for z, and we have the 5th power, so we're going to write 5 log base m of z, and we'll close our brackets like that. Remember, when you're taking the square root or any power of an expression, the power, the exponent will come out, and you'll need brackets. I hope you got that one. Now we're going to look at some problems which use the properties in reverse. So we're going to give you the problem and expect you to put it back together. Here's our example. We have 2 log m of a minus 3 log m of b squared. We might do this in 2 steps. First, we notice that 2 log m of a is going to be the log of base m of a squared. And then this 3 will become the exponent, so it's minus log base m of b squared cubed. We'll simplify that in a moment. Now we know that we have 2 logarithms subtracted, and when we're subtracting logarithms, we know that means we're dividing the numbers. Log base m, a squared is the numerator, and b squared cubed is b to the 6th power, and so we end up with b to the 6th in the denominator. Our final solution then is log base m of a squared over b to the 6th, and we're done. Although we use the bases of 10 and e a lot, sometimes we need to change bases from one form to another. We do this a lot when we need to use them with our calculators, since our calculators can only do base 10 and base e. Here's the change of base rule. It says for any positive real numbers x, a and b, a is not 1, b is not 1, the log base a of x that's our old base, is equal to the log base b, new base, of x divided by the log base b of a. What was a? A was our old base. Well, this turns out to be a very handy idea, because if we were looking for log base 15 of 5, our calculator can't do this, and unless we had some paper tables that told us what base 15 logs were, we wouldn't be able to do this problem. But thanks to the change of base rule, we can say this is the log of 5 divided by the log of 15. We could just as easily have used natural logs ln instead. Let's go over to our calculator and put these values in and see what the log base 15 of 5 actually turns out to be. We'll go over to our graphing calculator and we'll put in log of 5, close those parentheses, divided by the log of 15, close the parentheses. And we see that the answer comes out to be 0.594, etc., etc. So now we see how we can make those problem sets with different bases still be able to be solved with our calculator. Remember now, logarithms are exponents. Our notation is used for logarithms helps us solve equations with variables in exponents. The most common bases in use for logarithms are 10, called common logs, and e, called natural logs. We can use properties to master in both directions to simplify or expand the logarithm of an expression. You should practice until you're comfortable evaluating both expressions in both directions by applying the properties and using the change of base rule so that your calculator will become an effective tool.